MRL, let us learn about polygons. Now, what is a polygon? A polygon is a coplanar closed geometrical figure obtained by joining three or more non-collinear points by line segments which meet each other at their end points. So, we have a polygon here. ABC is a polygon, ABCD is also a polygon, and ABCD is also a polygon. Now, the features of a polygon are, first of all, the polygons are coplanar figures, that means they lie on a plane. They are closed figure, they are not open figures, they are closed figures. They are bounded by three or more line segments. Line segments meet each other at their endpoints called vertices. The line segments are the sides of a polygon. And if you observe here, A is a vertex, B is a vertex, C is a vertex, that means every polygon has vertices, every polygon has sides, they are closed and they are coplanar. So remember that every polygon has vertices, sides, angles, so that is what is common to every polygon. Remember that. The next point of our discussion is the naming of a polygon. A polygon is named by the number of the sides of a polygon. If there are 3 sides, then it is called as a triangle. If there are 4 sides, then it is called as a quadrilateral. If there are 5 sides, then it is called as a pentagon. 6 sides is a hexagon. 7 sides is heptagon. 8 sides octagon. 9 sides nonagon. And there can be a polygon of n sides also. So please remember that. Now, the diagonals of a polygon. If you look at this polygon, it has got A, B, C, D, 4 vertices, and all these 4 vertices, if you look at the vertices, AB is, they are adjacent vertices, BC are adjacent vertices, CD is adjacent vertices, and DA is also a pair of adjacent vertices. Whereas A and C are non-adjacent, B and D are non-adjacent. If I join a line segment from A to C, if I join a line segment or draw a line between A and C, then that is called as a diagonal. B and if I join BD, then that also is a diagonal. Therefore, a diagonal is a line segment joining any two non-consecutive or non-adjacent vertices. And since there are 2 pairs of non-adjacent vertices here, we have 2 diagonals in this polygon. Now, the diagonals, the number of diagonals from a vertex. Supposing now here there are 4 sides. Now there are 4 sides, and 4 minus 3 is 1. So therefore, there is 1 diagonal from each vertex. See, A has 1 diagonal, B has 1 diagonal, C has 1 diagonal, D has 1 diagonal. Therefore, there is only 1 diagonal from each vertex. Now, if you take this polygon, it is a 5-sided polygon, it is a pentagon, and there are 5 sides. 5 minus 3 is 2. Therefore, there are 2 diagonals from each vertex. Therefore, if there are n sides in a polygon, the number of diagonals from each vertex is n minus 3. 5 sides, 5 minus 3 is 2 diagonals. 4 sides, 4 minus 3 is 1 diagonal from each vertex. Remember that. Now, concave and convex polygons. A polygon is a concave polygon if one of the interior angles is a reflex angle, or the diagonals exist outside the polygon or is exterior to the polygon. Such a polygon is called as a concave polygon. Therefore, I have written here, a polygon is a concave polygon if one of the interior angles is a reflex angle. It is a reflex angle here, more than 180 degrees, and one of the diagonals is exterior to the polygon, is outside the polygon. Remember that. Now, a convex polygon means a polygon in which none of the interior angles are reflex angles, and all the diagonals are interior to the polygon. If you look here, angle A, B, C, D, E are all non-reflex angles, they are not reflex angles, and also all the diagonals lie inside the polygon. Now, the regular polygon and irregular polygons. A polygon of equal sides and equal angles is called as a regular polygon. The polygon is equilateral and equiangular. For example, square is a regular polygon because all the angles are equal and all the sides are equal. Irregular polygon, a polygon which has unequal sides or unequal angles, then it is a irregular polygon. Rectangle is a irregular polygon. Rhombus is also an irregular polygon. Now, simple and complex polygons. A polygon which has only one interior and the sides meet only at endpoints is called as a simple polygon. If you look at the polygon here, it has got only one interior and all the sides meet at the endpoints here. Now, there are no crossing of sides. Now in a complex polygon, a polygon which has more than one interior, we have got two interiors here, and also the sides cross each other, and therefore it is a complex polygon. Remember that. Now polygonal region, the part of a plane which lies within the boundary of the polygon is called as polygonal region or interior of polygon. Now area of a polygon, the measure of the polygonal region including its boundary is called as area of polygon. Angle sum property of a polygon, if you consider a triangle here, a triangle which has three sides and three angles, if I combine or add up the angle 1, 2 and 3 and we get a straight angle, that means angle 1 plus angle 2 plus angle 3 gives us a straight angle, and the straight angle is 180 degrees. Therefore the sum of the three angles of a triangle is always 180 degrees or supplementary. Now the sum of angles of a quadrilateral, the sum of the angles of a quadrilateral is 360 degrees, and it can be explained very easily. If I draw the diagonal BD, the quadrilateral gets divided into two triangles. The sum of the angles of triangle 1 is 180. The sum of the angles of triangle 2 is also 180. So 180 plus 180 becomes 360 degrees. Therefore the sum of the angles of a quadrilateral, that is angle A plus angle B plus angle C plus angle D, is 360 degrees. Remember that. Then now if the number of sides are 4, then the sum of the angles is n minus 2 into 180, and that is 4 minus 2 into 180, that is 360 degrees. The sum of the interior angles of any polygon is given by the relation n minus 2 into 180. Now for example, if you have 5 sides, then n minus 2 becomes 5 minus 2 into 180, that is 3 into 180, that is 540 degrees. Therefore the sum of the interior angles of a pentagon is 540 degrees. Now what is the sum of interiors of angles of a hexagon? Hexagon has 6 sides. 6 minus 2 into 180, 6 minus 2 is 4, 4 into 180 is 720 degrees. One interior angle of a regular polygon. Now this, how to find one interior angle of a regular polygon. A regular polygon means with the one which has got all angles equal and all sides equal. If a regular polygon has got n sides, the sum of the n interior angles will be given by the relation n minus 2 into 180. Now since we have to find out the measure of only one interior angle, then one interior angle is equal to n minus 2 divided by n into 180 degrees. Now let us take for an example, if we take a square which is a regular polygon, now the number of sides in a square are 4, n minus 2 by n into 180 becomes 4 minus 2 by 4 into 180, that is 4 minus 2 is 2, 2 by 4 into 180 is 90 degrees. Therefore one interior angle of a regular polygon, that is a square of 4 sides, which is of 4 sides, is 90 degrees. Now if it is a pentagon, n is equal to 5, one interior angle is equal to n minus 2 by n into 180, 5 minus 2 by 5 into 180, that is 3 by 5 into 180, and that is 108 degrees. So that is how we can find out the one interior angle of a regular polygon by knowing the relation n minus 2 by n into 180 degrees. The sum of exterior angles of a polygon, the sum of exterior angles of any polygon rather, is 360 degrees. Now for example, if I take a pentagon has 5 exterior angles, the sum of 5 exterior angles is 360 degrees. Now if you take a quadrilateral, the sum of the exterior angles of a quadrilateral is also 360 degrees. Here angle 5, angle 6, angle 7, angle 8 are exterior angles, and the sum of them is 360 degrees. Rather, the sum of the exterior angles of any polygon is 360 degrees. One exterior angle of a regular polygon. Now if you take a regular polygon, the sum of exterior angles is again 360 degrees. Since it has got n sides or n exterior angles, one exterior angle will be equal to 360 degrees divided by n. So therefore to find out one exterior angle of a square, then divide 360 by 4, that is 90 degrees. One exterior angle of a regular pentagon will be 360 divided by 5, that is 72 degrees. Remember that. So that is the method of finding out one exterior angle of a regular polygon. Now inscribed polygon. A polygon, the vertices of which lie on a circle is called as inscribed polygon. If you look here, it is a hexagon. The vertices of the hexagon lie on the circle, and therefore it is an inscribed polygon or inscribed hexagon. The sides of which also form the chords of circle is called as inscribed polygon. If you see here, the hexagon, the sides are the chords of the circle, and therefore it's inscribed polygon. So there are two ways of describing inscribed polygon, and remember that. inscribed regular polygon. A regular polygon, the vertices of which lie on a circle is called as a regular inscribed polygon. A regular polygon has equal sides and each side subtends equal angles at the center. The measure of each central angle formed by a polygon of n sides is 360 degrees by n. Now if you consider a hexagon, a regular hexagon, it has got 6 sides. Then the angle which is subtended at the center is 360 degrees by n, and that is 60 degrees. Remember that. Now circumscribed polygon. A polygon the sides of which touch the circle is called a circumscribed polygon. The sides of the polygon form tangents to the circle. Now if you look here, the polygon is a triangle here. The sides of the triangle touch the circle at P, Q and R. They are rather form the tangents to the circle, and that is called as a circumscribed triangle. The sides AB, BC and CA touch the circle at R, P and Q respectively. AB, BC, C are the tangents to the circle. R, P and Q are points of contact. The circle circumscribed by a triangle is called as the incircle. So therefore ABC is a circumscribed polygon, and it is circumscribing a circle, and the circle is called as incircle. So please remember this much and learn about the basics of polygons, and remember how to find out one interior angle or one exterior angle of a regular polygon using the relation. So that is what is about the polygons. In our next study we'll see the different types of polygons. Thank you.